Assalamualaikum dan selamat sejahtera. SK015 Chapter 1 Reaction Kinetics 1.1 Reaction Rate. At the end of the lesson, students should be able to define reaction rate, write differential rate equation, define rate law, order of reaction and half-life, write rate law respect to order of reaction, and write integrated rate equation for zero, first and second order. What is the reaction kinetics? Reaction kinetics is the study of chemical reaction with respect to the reaction rates. Chemical kinetic is the measurement of how quickly reactions to be occur. Definition: reaction rate. Reaction rate is the change in the concentration of reactant or product with time. The unit of the rate reaction is mole per liter per second, or you can write as molar per second. The relationship between rate and time is rate inversely proportional to the time. Bermaksud, kadar tindak balas adalah semakin meningkat jika masa yang diambil untuk tindak balas berlaku adalah pada masa yang pendek sahaja. Look at the example here. A produce B. A as your reactant and B as your product. So di sini, based on this equation, you can write two expressions. The first expression is rate equals to negative dA over dt. What means by D? D means change. dA means that change in concentration of A. dt refer to the period of time. Di sini, sign yang kita perlu masukkan adalah negatif. Kenapa? Because A as your reactant, so that concentration of A will decrease with the time. Untuk expression number 2 is rate equals to positive dB over dt. D means change. dB means that change in concentration of B over the period of time. Di sini kita masukkan positive sign because B as your product, so the concentration of B will increase with the time. Okay, so now I want to show you how the concentration of reactant and the concentration of product will change over the time. Alright, let's say A produce B, A as your reactant and B as your product. So di sini dalam diagram kita gambarkan particles A adalah black dot dan particles B adalah red dot. At the beginning, okay, kita dapati di dalam beaker itu hanya terdapat black dot. Hanya ada reaktan A sahaja. Ini menunjukkan tindak balas belum berlaku. Kemudian kita cek semula, 10 minit kemudian, didapati dalam kontainer tersebut ada red dot. Okay, tetapi hanya pada amount yang sedikit sahaja. Ini menunjukkan produk mulai dihasilkan. Okay, then at the end of the reaction, kita cek semula di dalam kontainer tersebut, didapati particles A wujud ataupun masih ada tetapi dalam amount yang amat sedikit. Manakala particles B amat banyak, iaitu warna merah ini. Okey, ini menunjukkan particles A semakin berkurang manakala particles B semakin meningkat. So based on this diagram, kita dapat buat conclusion, iaitu concentration of A will decrease with the time. That's why kita masukkan negative sign here. While the concentration of B will increase with the time. That's why kita tulis positive sign di sini. Okey, kalau kita tengok pada graf ini untuk menunjukkan curve itu semakin meningkat ataupun berkurang. Okey, so di sini pada permulaan at the beginning, okey, masa times equal to 0, particles B belum dihasilkan. That's why starting point for the curve of B is 0 here. Okey, manakala particles A telah ada di dalam kontainer tersebut. Di sini wakilkan dengan nilai 40 untuk particles A. Kemudian apabila tindak balas mulai berlaku, concentration of reactant A akan berkurang kerana telah diguna pakai untuk menghasilkan produk. That's why curve untuk concentration A semakin menurun. Manakala produk mulai terhasil. That's why curve untuk concentration B adalah semakin meningkat. Differential rate equation. Differential rate equation enables the relationship between the rate disappearance of reactants and the formation of product. Consider the reaction. You have A react with B, produce C and D. Based on this equation, you can write the differential rate equation. Kita akan menulis perkataan rate dahulu equals to dengan negatif. Kita letakkan sign negatif because species yang pertama adalah your reactant. So 1 over stoichiometric coefficient untuk A iaitu small letter A times change concentration of A over dt equals to negative 1 over B. Negatif sebab B ini adalah your reactant. Times change concentration B over dt equals to positive 1 over C. Kenapa positif? Because C ini adalah your product. Times change concentration C over dt equals to positive 1 over D times change concentration D over dt. This is we call as differential rate equation. Let me try example 1. Given the formation ammonia is 1 mole nitrogen react with 3 mole hydrogen to produce 2 mole ammonia gas. Based on this equation, you can write the differential rate equation. Kita start dengan menulis perkataan rate equals to negative. Kenapa? Kita merujuk kepada spesies yang pertama ini adalah your reactant. Since dia punya coefficient adalah 1, terus kita tulis change concentration nitrogen over dt equals to negative 1 over 3. Kenapa negatif? Because hydrogen adalah your reactant. Times change concentration hydrogen over dt equals to positive 1 over 2. Dua ini merujuk pada coefficient untuk ammonia. Ammonia adalah your product. That's why kita masukkan positive sign. Times change concentration ammonia over dt. So based on this differential rate equation, we can conclude that rate disappearance of nitrogen is 1 over 3 the rate disappearance of hydrogen and 1 over 2 the rate formation of ammonia. So di sini terms rate disappearance adalah merujuk kepada spesies reactant iaitu nitrogen dan juga hydrogen. While terms rate formation merujuk kepada spesies product iaitu ammonia. Exercise 1. Consider the reaction 2HI produce H2 and I2. A. Write the differential rate equation. So you start with the word rate equals to negative 1 over 2. Negatif sebab HI ini adalah your reactant. So times change concentration HI over dt equals to positive change concentration hydrogen over dt. Kenapa positif? Sebab hydrogen adalah your product. Equals to positive change concentration iodine over dt. Iodine also your product. That's why kita masukkan positive sign. So this is your answer for A. Now we go to B. Write the rate disappearance of HI. Di sini kita hanya merujuk kepada satu spesies sahaja iaitu HI. Rate disappearance ini diguna pakai hanya untuk spesies iaitu reactant. So we start with the word rate equals to negative. Sebab HI ini adalah reactant. Okay. Change concentration HI over dt. So di sini kita tidak perlu masukkan dia punya coefficient because expression rate disappearance ini hanya merujuk kepada satu spesies saja. That's why tidak perlu masukkan dia punya coefficient di dalam this expression. So this is your answer. Okay, untuk C, rate formation of I2 and H2. So di sini sekali lagi kita nak buat expression untuk iodine dan juga hydrogen. So kita memerlukan dua expression. So the first one, write the rate equals to positive. Kenapa positif? Sebab iodine adalah your product. So change concentration iodine over dt. Ini expression yang pertama. Expression yang kedua untuk hydrogen adalah tulis perkataan rate equals to positive. Kenapa positif? Hydrogen also your product. So change concentration hydrogen over dt. So this is expression untuk yang kedua. Okay, now you have to know what is the definition for rate law. Rate law expresses the relationship of the rate of reaction to the rate constant and the concentration of reactant raised to some powers. So, if you want to define the rate law, key term yang pertama kena ada adalah rate constant dan key term yang kedua adalah concentration reactant raised some powers. For your information, rate law also known as rate equation. Since rate constant adalah salah satu key term untuk define the rate law, you have to know what means by rate constant. Rate constant, the symbol is small letter k. Rate constant is a constant of proportionality between the reaction rate and the concentration of reactants. The value of rate constant actually depends on specific reaction, order of reaction, temperature, or catalyst. Actually, generally, nilai untuk rate constant adalah small number. It can be positive or negative. Semakin besar nilai rate constant, semakin cepat tindak balas berlaku. As I said before, the rate constant is depend on the order of reaction. Order of reaction is the sum of the powers to which all reactant concentrations in the rate law are raised. Reaction orders are determined by experiment. Reaction orders are not the stoichiometric coefficients. Definition half-life. Half-life is the time required for the concentration of reactant to decrease to half of its initial value. Now I want to show you how to write the rate law with respect to order of reaction. Let's say you have this equation, A react with B, produce C and D. So your rate law is rate equals to K times concentration reactant A power of X times concentration reactant B power of Y. So K here means rate constant. X and Y here refer to reaction order. So cara baca X dan Y adalah reaction order is X with respect to A. Reaction order is Y with respect to B. So di sini kita boleh kira overall reaction order which is nilai X tambah dengan nilai Y. X and Y can be integers, fractions, decimal or negative values. X and Y can only be determined by experimentally. Reaction order usually defined in terms of reactant concentration. Don't forget, reaction order is not related to the stoichiometric coefficients. For example, you have this equation, F2 plus 2ClO2 produce 2FClO2. If the order with respect to F2 and ClO2 is first order, write the rate equation for this reaction. As I said before, rate law also known as rate equation. So, the question asks you to write the rate law. So, you must start with the words rate equals to small letter k, which is rate constant, times the concentration of reactant. So your first reactant is F2. Power of its reaction order. Order respect to F2 is first order, so power of 1. Times the concentration reactant. The second reactant here is ClO2. Power of its reaction order respect to CO2 is first order, that's why power of 1. So this is your rate law. Zero order reaction. Zero order reaction is reaction independent of the concentration of reactant. Let's say A produce product. So A is zero order reaction. So based on this, you can write the rate law, which is rate equals to K times concentration reactant A, power of reaction order for this A is 0. So we can simplify this rate law because concentration A, power of 0 will become 1. So you can write like this, rate equals to K. So let we try exercise 1 here by referring to the equation below. A produce B. Given reaction order is 0 with respect to A. So write the rate law for this reaction and state the overall order of reaction. So for A, you want to write the rate law. We start with the word rate equals to K times concentration reactant A, power of reaction order respect to A is 0. So you can simplify this rate law, which is rate equals to K, because concentration A power of 0 will becomes 1. So the overall order is X plus Y if you have two reactants. But for this case, you only have one reactant. So the answer is 0 order. Next, first order reaction. First order reaction is reaction whereby its rate depends on the concentration of reactant raised to the first power. Let's say you have A reactant produce the product. So based on this, you can write the rate law, which is rate equals to K times the concentration reactant A power of its order of reaction, which is 1. Let's say A is a first order. So this is your rate law for first order. Exercise 2. By referring to the equation below, A plus B produce C. Reaction order is 0 with respect to A. Reaction order is 1 with respect to B. So write the rate law and state the overall order of reaction. So for question number 1A, you want to write the rate law. So rate equals to K time concentration reactant A power of its reaction order. Reaction order respect to A is 0. Power of 0 times concentration reactant B power its order, which is 1. So here we can simplify this rate law, because concentration reactant A power of 0 will becomes 1. So rate equals to K times concentration reactant B power of 1. Okay, for overall order, you just sum up the reaction order for A and B, which is 0 plus 1 will become 1. So the answer is first order. Second order reaction. Second order reaction is a reaction which depends on the concentration one reactant raised to the second power, or two different reactants raised to the first power. So, apa yang dimaksudkan dengan ayat ini adalah jika you ada hanya satu saja reactant, iaitu let's say A, this reactant akan raised to the second power. Maksudnya akan dikuasakan dengan 2. Ini juga menunjukkan dia akan undergo second order reaction. Ataupun you ada dua reactant, let's say A and B, tetapi setiap satu reactant ini mesti dikuasakan dengan 1 raised to first power. Because kita nak hasilkan this reactant menghasilkan second order reaction juga. Okay, so let's say lah you have A produce product here, di mana hanya ada satu saja reactant. So di sini kita boleh tulis dia punya rate law. Okay, so rate equals to K times concentration reactant A. Kita hanya ada satu saja reactant, iaitu A. So kita akan terus power dengan 2 untuk menunjukkan dia adalah second order. Okay, so we try exercise 3 here. By referring to the equation below, A plus B produce C. Reaction order is 1 respect to A. Reaction order is 1 respect to B. So write the rate law and state overall order reaction. So untuk A, kita nak tulis dia punya rate law, iaitu rate equals to K times concentration reactant yang pertama, iaitu A, power of its reaction order. Di sini telah nyatakan reaction order respect to A adalah 1. So, power of 1 times concentration reactant B, power of 1 also. Sebab di sini telah nyatakan reaction order respect to B adalah 1. So, this is your rate law untuk soalan A. Untuk B, overall order adalah sum up nilai reaction order reactant A dan reactant B. So, di sini 1 plus 1 produce 2. So, the answer is second order. Now, we want to write integrated rate equations. For zero order, we integrate this equation. You will write concentration A naught minus concentration A equals to KT. This refers to the initial concentration of A. This refers to the concentration A after time T. K refers to the rate constant. This is integrated rate equation for zero order. First order, we integrate this equation, you'll get ln concentration A naught minus ln concentration A equals to KT, or you can write like this, ln concentration A naught over concentration A equals to KT. For second order, we integrate this equation, you'll get 1 over concentration A minus 1 over concentration A naught equals to KT. As conclusion, kamu telah mempelajari definition reaction rate, half-life, order of reaction, rate constant, and rate law, and how to write rate law and how to write integrated rate equation. That's all. Thank you.